Stavroula Katsogianni, talking about urban trees and climate adaptation.
I'm very happy to be with you today, here to this fantastic city. And we'll speak about trees and climate adaptation. The climate adaptation of urban trees is a big chapter for scientists and practitioners who need to move away from the literature on the benefits of trees to focus on mitigating the effects of climate change through green development. Climate change leads to extreme weather phenomenon, which in turn strain the natural resource systems that support urban ecosystems. What is going to change in the coming years? No one can be certain of what will happen exactly. There are various scenarios. The only certain prediction is an increased duration and frequency of drier summers and extreme weather events. What will these changes cause? As an example, just from temperature rise that directly affects plants, we can observe the following alterations. Reduction of photosynthetic capacity, increased breathing rate, decreased nutrient absorption, leaf damage, crown wear and tear, early flowering, reduced growth rates, changes of shoot burst time, and of course, mortality. In this table, we can see examples of tree and plant related responses to climate change in various regions of the planet. In order to study the effects of climate change in urban areas, phenological gardens were created. The science of phenology studies changes in the life cycle of plants. Some of these gardens, as I know, are financed through the European program Life Climate, with partners Greece, Italy, and Portugal. Tree mortality will increase due to drought, damage from extreme snowfall, storms, fires, lack of available resources, and of course, from attacks by insects, fungi, bacteria, etc. In these pictures, you can see problems encountered by two types of urban trees we often use in Greece. The mulberry tree is affected by the insect Xylotrechus sinensis and the plane trees for the fungus Keratokystis platani. No matter how direct or indirect the effects of climate change on plants are, the result will be changes to the characteristics and compositions of the urban landscape as we know it, and eventually change in the perception of each place or city identity. The adaptation of urban trees to current and projected climate impacts is very important. Yet, few efforts have been made to systematically assess the vulnerability of urban trees with the goal of disseminating and incorporating the results into decision-making or further action. How vulnerable are urban tree populations to projected climate change? Typically, climate change vulnerability assessments define vulnerability as a function of exposure risk, sensitivity, and adaptive capacity. Nevertheless, according to studies, the determining factor of a tree's vulnerability in a city is the tree's projected shift in the heat and hardiness zone. In the USA maps, we see within a few years, for example, Zones 8 areas shifting to Zone 7 and Zone 6 areas to Zone 5. What factors affect the growth of urban trees in these years? It has been widely established that precipitation and temperature during the growing season are the main climatic variables affecting growth for most tree species worldwide. A temperature increase can have positive effects on growth only when these increases are relatively moderate and while sufficient moisture is available. In most cases, trees can only cope with ambient temperatures above 40 degrees Celsius for short periods of time and provided there is sufficient moisture in the soil. In urban landscapes, trees may be watered regularly, but are the available resources sufficient? In Shanghai, an assessment framework was proposed and applied to assess the climate change adaptability of 65 urban tree species. In this study, the climate types of tree species were divided into 4 groups according to annual mean temperature and annual precipitation: temperate, cool subtropical, warm subtropical, and moist subtropical species. The results showed that the warm subtropical species had higher stress tolerance and other climate types in the Shanghai area. So trees such as Quercus virginiana, Quercus texana were suitable alternatives due to their relatively higher climate adaptability and stress tolerance. Another example is coming from Edmonton region in Canada. In the list, we see 3 species that should be preferred over others due to their resistance to drought. In light of these new conditions, we should study the adaptivity of urban trees with the aims of slowing the change and loss of ecosystems, building resilience, transitioning ecosystems to the new conditions, and we can do it by protecting resources, preventing the introduction or establishment of new invasive plants while removing existing ones, improving tree health, maintaining, enhancing native species diversity, designing planting projects with high species diversity, selecting tree species to match current and future site conditions, etc. Resisting change and building resilience to climate change can be achieved by investing in nature-based solutions. There are many benefits, including flood protection, increased water reserves, carbon sequestration, etc. Some benefits of nature-based solutions appear in the short time, others gradually over time. The 2 most important benefits, in my opinion, are water management and soil restoration. There must be extra attention for rainwater storage and reuse, and the quality of urban soils as growing places and source for carbon dioxide storage. Urban land is a critical factor for climate resilience. It is a foundation for healthy, functional ecosystem. Historically, cities have failed to sustainably manage their land, resulting in its continuous degradation. Best practices for urban soil management should aim to protect against compaction, improve soil structure and composition, increase the volume of soil available for root development, and increase geodiversity. A collective action plan for the adaptation of urban trees to climate change requires the formation of partnerships among municipalities, academics, professionals, associations, and others to share knowledge, to identify research and technology priorities, to identify funding requirements, and find the resources for implementation. On June 17, 2024, that happens before a few days, the Environment Council of the European Union adopted the Nature Restoration Law. The Natural Restoration Law aims to prevent the loss of green spaces and trees in cities by 2030. From 2030 to 2050, national and local urban restoration plans will be implemented. So we need to prepare with an action plan that can be divided into 4 parts and will include policy, new plantings, tree management, risk management. We need a strategy for the development and management of urban trees that will give direction, such as incorporate climate adaptation strategies, protect areas with representative urban forest types, establish or improve connections among green spaces at the municipality areas and regional areas, outline best practices, guidelines and standards for public and private projects, collect, disseminate statistical data, create regional nurseries that can cultivate trees with climate-resistant genetic material. Let's face the fragility and mortality of urban trees as an opportunity to create more resilient and purposeful greenery. Diversity is one key to a successful tree planting program. Overplanting one species in an area can lead to monocultures that encourage the concentration of insects and diseases, which can destroy a large proportion of the trees in an urban area. A reasonable strategy for most urban planting is limit any species to between 5 and 10% of the total. So if any disease or insect infestation occurs, 90–95% of the population tree will remain unaffected. Select suitable species for the location, taking current and future climatic conditions into consideration. Create the conditions for a healthy tree growth by investing in larger volumes of soil for the development of the root system and by restoring hydrology, permeability and the cycle of nutrients. Implement pilot plantings of new tree species resistant to the drier climate, diseases and pests. Stavros Niarchos Park is a new park in Athens with an area of 180 acres. It includes only 16 kinds of trees, of which 90% are plane and olive trees. Phytophthora and Verticillium fungi have recently attacked the trees, seriously threatening the viability of most of them. The goal is to maximize tree life. Urban trees usually require investive management because they live in harsh conditions away from their native environments. Preventing and implementing good urban tree management practices create resilient urban ecosystems. So we need budget increases to implement management plans, identification and control of invasive plants and insects, and of course training staff in proper tree management. Many municipalities regularly inspect trees to assess their health conditions and to identify appropriate pruning requirements. Risk management needs inspection and risk assessment of trees, especially located near critical and sensitive points in the city. Development of community wildfire protection plans and extreme weather plans, and of course restoration plans. Urban trees are the unique assets that, unlike the rest of a city's infrastructure, increase in value as they grow, providing their greatest benefits at maturity. Therefore, we must fight for urban trees to provide them with long, healthy lives. So, what is our role? Our role as scientists and arborists is complex. We are responsible for selecting new species, creating specifications, managing new trees, protecting existing ones, etc., etc. Every year, the planting of thousands of trees is announced by municipalities with the goal of reducing the effects of climate change. It's like a pre-election contest by the mayors who promise to plant 1,000, 10,000 or 100,000 trees. But what kind of trees will these be? With what specifications will they be planted? How will they be managed so they can grow? A study in London mentioned that 32% to 50% of newly planted urban trees do not reach the age of 10 years. Until now, we have decided on species selection and urban tree management practices based on tradition, history, habit, and aesthetics. However, as the climate change decisions need to be based on scientific data and knowledge of the ecology, anatomy, morphology, and physiology of suitable urban spaces. In this table, for example, you can see adaptation mechanism to aridity from Australia tree species. There is relatively little data on urban tree species. Forestry and agricultural research can be exploited, and we should be funding such research, and experimental pilot planning should be undertaken as well. This knowledge then need to disseminate it to municipality officers, professionals, green space designers, green managers, etc. We have a lot of work to do, but I think the most difficult part is to convince the decision makers that trees need more than a bit of soil. They need planning, knowledge, natural resources, professionals, money, and vigilance to grow. Thank you very much.